Integrals for mass calculations. Find the mass and centroid of the following thin plate. Assume constant density. Our region, you might notice if you look at it carefully, is strictly in the first quadrant, and that's because it's bounded by the curve and the x-axis. That forces it to be in the first quadrant. And then, so x is going to run from 1 to, they gave us a value of e. So y runs from 0 to log x runs from 1 to e. And that puts us in the first quadrant, the area above the x-axis and below the curve. And we need to find that center of mass. Let's look at the formulas for center of mass. One thing I want to point out is that they told us that our density is constant. And if you look at the fact that x bar and y bar are ratios with that constant value both in the numerator and in the denominator, that constant value is going to cancel. So I'm going to be making the claim that rho is equal to 1, and that works out fine because whatever rho is, it would cancel anyway. Alright, so let's first find the moment with respect to the y-axis, and that will help us to find x bar. So I'm integrating over the given region, and I have and the way that you find the moment with respect to the y-axis is you go x times the density function. But of course, we've said that our density function in this case is equal to 1. And so this is my integral. Integrate with respect to y first, and I get this integral. Now notice that an integral like this requires integration by parts. So let's set up integration by parts with u being ln of x and dv being x dx. So let's go ahead and do that. If u equals ln of x and dv equals x dx, then du is 1 over x dx, and v is x squared over 2. And so the integral of u dv is equal to u times v minus the integral of v du. Let's go ahead and evaluate the first part. Keep in mind when you evaluate that log of e is equal to 1 and log of 1 is equal to 0. And so the piece on the left is just e squared divided by 2 minus 0. Then notice also in my integrand I have simplified. I had x squared and in the numerator, and I have x in the denominator, and so that just simplifies to x. And that's not very difficult to integrate. So go ahead and integrate that and evaluate it. And I find that my moment with respect to the y-axis is e squared divided by 4 plus a fourth. Now let's work on the moment with respect to the x-axis. First, we integrate with respect to y. And when we integrate with respect to y, we then evaluate, and we get this. Now this is going to require 2 applications of integration by parts. So start off with our integration by parts of u equals ln of x quantity squared divided by 2. If u equals ln of x quantity squared divided by 2, then du would be ln of x then times the derivative of what's inside, 1 over x. So I had to use the chain rule there. And then the dv is a little bit easier. If dv is dx, then v is just equal to x. Set up your integration by parts, and then go ahead and evaluate that first piece. All right, now we've evaluated the the first piece, and now we have one more integral. Now this integral does require another integration by parts, and so let's go ahead and do it. Have u be ln of x and dv be dx. Then du is 1 over x dx and v is x. Do your setup, and you finally end up with something that's fairly easy to integrate. And when the dust settles, you have e divided by 2 minus 1. All right, so this required a couple of applications of integration by parts, but just by being persistent, we were able to do it. So we have our moment with respect to y-axis and the moment with respect to the x-axis. One last thing we need to do is we need to find the mass of the plate. Well, integrate with respect to the y-axis, and we get this integral. Now, we've just integrated this. Just 30 seconds ago, we integrated an integral just like this. We had u equal log x, and then du would be 1 over x dx. V is, I have a typo there. It says dv equals x dx. Let me fix that for you. Okay, I have it fixed now. So u equals log x, du equals 1 over x dx, dv equals dx, and so v equals x. And do my my integration by parts, and I'm left with a mass of 1. All right, so we now are able to find x bar and y bar and put that into our answer in MyMathLab, and we're all done. Great job. Thanks, and I'll see you next time.